Given two similar parallelopipeds, we'll show that parallelepiped AB to parallelepiped CD is proportional to the cube of AE to CF, where AE and CF are corresponding sides, and the exponents says it's a triplicate ratio. To review triplicate ratios, we have four numbers in continued ratio, like 1 to a squared to a cubed, and we say that a cubed to 1, the fourth to the first, is in the triplicate ratio of a to 1, the second to the first, because a over 1 cubed is equal to a cubed over 1. So the ratio describes volume. First, let's copy parallelepiped CD to the E corner of parallelepiped AB so that the edges all line up. This gives us parallelepiped KP equal to parallelepiped CD. Next, make the parallelogram GK again with edges lined up, and then take parallelogram GK and KL and extend them to the same height as parallelepiped AB. Now, parallelepiped CD is similar to parallelepiped AB, so their sides are proportional, namely, AE to CF is proportional to EG to FN, which is proportional to EH to FR. Parallelepiped PK is equal to parallelepiped CD, so let's substitute its sides in to get AE to EK being proportional to EG to EL being proportional to EH to EM. Focus on the parallelogram AG plus GK. We've shown previously in proposition 6.1 that AE to EK is proportional to parallelogram AG to parallelogram GK, and the same goes for EG to EL being proportional to parallelogram GK to parallelogram KL, and EH to EM being proportional to parallelogram QE to parallelogram KM. Putting this together shows parallelograms AG to GK is proportional to GK to KL, which is proportional to QE to KM. But we showed in the previous proposition that parallelepipeds of the same height are in the same ratio as their bases, so focusing on parallelepipeds AB and OE, parallelogram AG to parallelogram GK is proportional to parallelepiped AB to parallelepiped OE. Similarly, parallelogram GK to parallelogram KL is proportional to parallelepiped OE to parallelepiped QL, and parallelogram QE to parallelogram KM is proportional to parallelepiped KL to parallelepiped KP. Putting all those together shows that parallelepiped AB to parallelepiped OE is proportional to parallelepiped OE to parallelepiped QL, which is proportional to parallelepiped QL to parallelepiped KP. Thus, we have four solids in continued proportion, so the fourth to the first, parallelepiped AB to parallelepiped KP, is the triplicate ratio of the second to the first, parallelepiped AB to parallelepiped OE. But parallelepiped AB to parallelepiped OE is proportional to parallelogram AG to parallelogram GK, which is proportional to AE to EK, so parallelepiped AB to parallelepiped KP is proportional to the triplicate ratio of AE to EK. But parallelepiped KP is proportional to parallelepiped CD, and EK equals CF, so parallelepiped AB to parallelepiped CD is proportional to the triplicate ratio of AE to CF, which is what we are to show. The poism just says four numbers in continued proportion are analogous to volumes.